everyone hear me? Is this working?
Yeah.
Yep, brilliant.
Yep.
Cool. Right, firstly, I would like to thank OpenSIPS for inviting me back once again to do another talk.
Yours.
This talk will be working. It's actually a workshop. I've sort of worked for the last 15 years developing sort of highly scalable, large-scale applications, web applications, telephony applications, all kind of applications. And sort of in that vein, I run a company in the UK, and we do voice over IP, mainly OpenSIPS software development and consultancy. We've got some reasonably large customers, and we're used to dealing with OpenSIPS asterisk, FreeSwitch, Rabbit, sort of all the standard integration elements that you get with these kind of technologies. Now the workshop today, the aims are to demonstrate the new WebSocket module that's available in OpenSIPS since version 2.1. Now this was a big deal in version 2.1. I believe they rewrote the TCP stack, and whilst they were doing that, they added the ability to make WebSocket connections. Now the big thing about WebSocket connections is it means that a web browser can now talk to OpenSIPS. So I'm going to demonstrate the new WebSocket module. It's now been evolved to support secure WebSockets in OpenSIPS 2.2. I'm going to demonstrate how a browser can now become a SIP user agent with OpenSIPS obviously as the proxy. And I'm also going to demonstrate, if there's time, how you can also then get a browser to talk to the public telephone network. And there will be some live and exciting real-time OpenSIPS configuration. There's a little bit of background. The slides really are for, so hopefully if anyone wants to read back when the presentation is published, so for the bullet points will kind of just make the points that I'm trying to make. So WebRTC is a new standard, and it defines how browser-to-browser media sessions can be established. And it's been ongoing since, I think, before 2011, and they've been trying to, Google at least have been trying to push the standard and trying to get the ability for browsers to talk to each other. And as of this year, there's decent support in Chrome and Firefox. I believe there's Android browser support and iOS support that I've seen people using. And it's really a nice standard way that web browsers can use to talk to each other using audio and video. They're standard on the way they're going to encrypt audio and video, and they have also got this nice way of getting around NAT issues using something called ICE. If anyone has ever tried to deal with NAT using OpenSIPS and RTP proxy before, you'll know that you have to play about with stun servers, turn servers, you have to tell people to configure their clients and put special settings in and try TCP and UDP. Whereas the NAT traversal that WebRTC defines means that the browser itself goes away and gets a huge SDP packet with lots and lots of options and candidates in there for media, and they basically just work it out between themselves, which is great. So hopefully on a sort of a network, I'm going to demonstrate later a live WebRTC call, so hopefully on a network such as we're on in this hotel. Previously there would have been lots of question marks over whether the media would work, but hopefully using WebRTC it will just work, and the browsers will negotiate between themselves a sort of a media path. One thing to note is that WebRTC does not equal SIP. It's transport agnostic. It's just the method the browsers use to communicate with each other. However, as we all know, SIP can carry SDP transport, which is great. OpenSIPS supports WebSocket connections. Browsers can now make WebSocket connections. So we have this nice situation where we can have a browser that has WebRTC support, browser WebSocket support, OpenSIPS WebSocket support, and that means we can now make audio and video calls from a browser using OpenSIPS, and that's what I'm going to demonstrate now. So, can everybody read that? Is that a yes?
There you go.
That's better.
Birdie.
Okay. I've got a really long host name. Okay, so this is a DigitalOcean virtual machine that I've just spun up in the cloud. And I basically installed the latest version of the OpenSIPS 2.2. Here, I've just literally downloaded it, done a make and a make install, and have a fully vanilla OpenSIPS configuration file, exactly as it comes from the downloaded version of OpenSIPS. On this server, I also have an Apache web server running, and there's a very simple HTML page running. It's got some JavaScript in there, jQuery library loaded. There is a nice JavaScript library available called SIP.js, which I believe is maintained by another company who are supporters of OpenSIPS. You still hear me? And then we have a little bit of JavaScript which accesses various HTML elements on the page. And at the very bottom, a very, very simple piece of HTML which will allow us to register a user agent. It will allow us to make a call to another user agent, and it will also allow us to make a PSTN call. It's kind of outside of the remit of this talk to go into the details of how this website works. I'm just going to move this.
Peter, will there be a copy of this script available?
Yes, certainly, yeah. So, just a very quick overview. We're basically saying when the document's ready, if somebody clicks the register link, then we're going to create a SIP user agent. We're going to open a WebSocket connection to this server, which we're going to configure later, and we are going to register. Later on, you can see that if we receive an invite, so there we are, we have user agent on invite, then we will accept the session, and we will render the remote video in an element that's defined below, and we can then have a further, here we say if we are making a PSTN call, then we will create our own invite to the PSTN, and again we will put the remote audio on an element that's defined later on. As simple as that. So I'll just call up the web page so you can see what it looks like. It's not very exciting. This one. Apache running on port 4443. It's very simple. It will allow you to register. So this web page is essentially a user agent. So I'm going to demonstrate us registering over WebSockets to OpenSIPS, but first we need to change the OpenSIPS configuration. So as I say, it's the vanilla OpenSIPS configuration. You know, I can stop this from screen.
Yeah, let's come this way. There.
So we have a vanilla OpenSIPS configuration file. By default, OpenSIPS will only listen on the local host, but we need to make OpenSIPS listen on the public IP address, which is here. got some firewall rules on this machine, so it hopefully should come an open relay when we do this. And we also want OpenSIPS to listen on the WebSocket protocol, so we also need to define WebSockets, and we're going to listen on port 443 for the inbound WebSocket connections. Now, going down to the section where you load modules, by default OpenSIPS loads the UDP module, but we also need to load in the WebSocket secure module. So we'll do that now. And I'll just go and check the documentation for WebSocket secure. And see if there's anything else that we need to configure. We've already said we're going to listen for inbound WebSocket secure connections. We're already using the default port 443. I'm going to increase the maximum number of message chunks that OpenSIPS will look over for a request. I believe this essentially is the number of TCP packets that OpenSIPS will keep looking at to see whether it's got a full request. And in my experience, 8 is sometimes not enough because, as you'll see later, the huge SDPs that get generated by the web browser can sometimes be very big packets for the invite. So increase that from 8 packets to 16 packets, and I believe that's the only configuration option we need. Now, WSS stands for WebSocket Secure, so we also need to load up the TLS management module. TLS MGM, I think, has been renamed to in 2.2. Just double check. Yeah, so we have the TLS management module, which OpenSIPS uses to manage TLS connections. So you can use this to listen for regular inbound TLS connections, and also the WSS module will also make use of it when it needs to accept inbound TLS connections. We need to configure up some SSL certificates. So first we'll generate some. This will be a handy script in here. Gensert, just a very simple OpenSSL command. It will generate a certificate here, and it will generate a key file here. And we can give that information to both OpenSIPS and Apache, and it will use those dummy certificates to accept inbound TLS connections. So I'll just generate a new one now. Yeah, just give it some fake information because it's just a test certificate. So we should have in etc SSL local certs. We should now have the certificate and key, today's date information. Yeah, mycert.pen. So we can insert this information into OpenSIPS. Tell it where the certificate is, and we also need to tell it where the private key is. Called key. I'll just check that this is the name of the file. Yep. So we've loaded the TLS management module. We have told OpenSIPS about the certificate, and we've told OpenSIPS about the private key. I'm just going to run through some of the other configuration options for TLS management that are important for us here. This one here, verify certificate. We're going to tell OpenSIPS not to bother verifying the certificate because we're just doing a demonstration. It's not a real SSL certificate, it's one we've generated ourselves. And we're also going to tell OpenSIPS not to bother requiring the certificate. So that's pretty much all we actually should need in order for OpenSIPS to accept inbound secure WebSocket connections. SSL certificate is there. We have got the listen interface defined, so OpenSIPS will be listening on port 443 for inbound connections. We have our user agent written in JavaScript, so we should now be able to restart OpenSIPS, fire up our user agent and make a registration. So, fingers crossed. Yeah, so OpenSIPS is running. Should be listening on port 443. Yes, it is. I'm just going to restart Apache as well because it's using the same SSL certificates, which have just been regenerated. Okay, so here we have our user agent, new SSL certificates that we need to accept. They've been accepted. So if I register now as the user Peter, just show that again. One of the nice things about this JavaScript library is it will show you the SIP messages that it's sending into the server. One of the problems with doing things over secure WebSockets is that everything's encrypted, so you can't view the traces very easily. Unfortunately, with this library, we'll dump in the JavaScript logs for you. So I'll register. As you can see here, the library has opened up a WebSocket connection to OpenSIPS, and it has sent a register message into OpenSIPS, register request, and we have a 200 OK reply. So we should see in OpenSIPS that registration. So here we are. I registered as Peter, and we have the Peter registration stored in OpenSIPS' location database. Now we have a problem because this register request has come from the browser, and the web browser is not able to have access to the local IP of the machine, so it has to send in a valid domain. I believe as per the RFC. So basically, what the client has done is basically made up a random string, .invalid, so it looks like a valid domain. This is what will have been put into the contact header. So we see that the contact header here, and it's also the first buyer header that's been sent into OpenSIPS. Now, normally these headers contain the IP address and the port that OpenSIPS will be able to use to reach this user agent. And OpenSIPS has dutifully received that information and has stored it here. But obviously, if someone now tries to make a call to Peter, OpenSIPS is then going to try and send that call to this destination, which obviously is not routable. So what we need to do is we need to use some of the NAT handling features in OpenSIPS just to get around this hurdle that WebRTC has put in our way. So I'm just going to quickly make that change to the OpenSIPS script now. So we need to load up the NAT helper module. Quick look at the documentation. We've loaded the NAT helper module. And we also need to define within this module the received AVP. So I'll just quickly paste that in. And then we also need to define the same parameter for the registrar module. So what this is about the source port and the source IP, from where the packet was received into this AVP. And AVP is essentially a variable in OpenSIPS. So as the packet arrives and will invoke a NAT helper function later on in the script, it will store the source IP and source port in this AVP, and then the registrar module, which is the module used to save information about registers, that will then read from the same variable so that it will know where to send any requests for this user. So I'll just show you documentation. Yeah, the received AVP used to store the URI containing the received IP, port, and the protocol. And again, it goes on to say the URI is created by a fixed NAT and register function, and this is the function we're going to use when we receive a registration from an inbound WebSocket connection. So I'll just go to the part of the script where registrations are dealt with, and that is here. So it's very simple. As the box configuration from OpenSIPS, it doesn't do any authorization. It just says if you sent me a register, I'm going to save the information to my location database. Normally in here, I imagine if you were running a production platform, you'd have some challenges and authorizations at this point in the script. But here what we're going to do is we're going to detect the protocol. So we're going to say if the protocol is equal to WebSocket secure, then we're going to call the fixed NAT and register function. And that function will literally there we go. Again, the function creates a URI consisting of the source IP, port, and protocol, and stores the URI in the AVP that we've defined, because, as I say, it will then essentially replace this via header or this contact header, which is invalid, and the registration module will then store that information in place of the bogus information. So we should simply be able to restart OpenSIPS. You actually see that the JavaScript library, so it's 1405 at the moment, the JavaScript library actually detected that OpenSIP was restarted because the WebSocket connection was torn down, and it's immediately tried to re-establish it, succeeded, it's re-registered again. So it's quite a nice little JavaScript library that you can use to create this user agent. And you'll notice straight away that the new information has been stored against the record for the user Peter. We now have this information about how we can then send any requests to Peter in the future. Let's scroll up, you'll see that information wasn't stored previously. There's no received parameter there. Okay, so we have successfully managed to register our JavaScript user agent, and we should now be able to demonstrate making a call between two user agents. I'll register another one, Bob, and you will see there's now two registrations. And interestingly, the first one from Peter, there will be two WebSocket connections now from my browser here to the OpenSIPS server. The first one has come from port 50438, and the second one has come from port 50455. And when we run the netstack command, we'll see OpenSIPS here listening on port 443, and we have an established connection to port 50438, and we also have an established connection to port 50455. And this is the WebSocket connection that's established from the browser to OpenSIPS. Okay. So I'm not going to make the call, I'm just going to make one more change to the OpenSIPS configuration. In fact, I will make the call and I can demonstrate what the change is going to be. So Peter and Bob are registered, so Peter is going to call Bob. I'll click the call button, and then we should see some information coming through the logs in the JavaScript logs. So what the browser will do is it will gather the ICE candidates, and then it will send a very large invite into OpenSIPS. And as you can see here, we have this huge SDP It's not as small as normal. Normal SDP would usually contain just one IP address, one port. As you can see, this one, we have lots and lots of candidates that have been generated, which I believe is lots of paths that the other user agent can use to reach this one. We have some key information, password information, because the media is encrypted by standard for a WebRTC call. And we have an audio section and we have a video section. So we have this huge invite packet that's been sent to OpenSIPS. But again, we have a problem because we have the invite request here, but as you can see, the contact header again is a random string essentially. It doesn't make any sense to OpenSIPS, and OpenSIPS will not know how to send a 200 OK message back to this user agent. Or at least it will not know how to send an ACK back, sorry. And yeah, as you can see, the call is frozen because the user agent has probably given up trying to establish the call properly. So we just made another change to OpenSIPS, again to handle the NAT situation for the call as opposed to the register. So previously we edited the register part of the OpenSIPS script and we fixed the NAT for the register. This time we need to look for the invite part of the script, which is here, and we need to fix the NAT information for invites. And again, we just call a function called fix natted contact, and we'll just find the documentation for this. Fix natted contact. It rewrites the contact header field to contain, as before, the source address and the port. And this is so OpenSIPS will know how to route future requests back to this user agent that's presenting itself from behind what is essentially a NAT. So we need to do this for the invite, and we also need to do this for the reply to the invite. Okay. Restart.
It's two T's, right?
Not fix natty contact, I don't think. No, that's right, I think.
Okay, sorry.
Should we find out? Yep. So OpenSIPS is restarted once again, and we have no registrations. So I reloaded the user agents. So I will register this one as Peter, and register this one as Bob again. And this time the call should succeed, and we should get audio and video between both user agents. So I'll call Bob from Peter. Bob is seeing an incoming call. And there we go. We have audio and video. I don't know if anyone else wants to load up this web page so we can have a video call that's not just me talking to me.
Hold it in Slack, Andy.
Sorry?
Hold it in Slack, like.
Yeah. It's not working. I will do later.
What is the IRC channel?
Yeah?
The IRC channel, the link.
Okay. Do you want to try it now, or do you want me to just do it for later?
No, we can try now. If you want to. We still want to do that.
Yeah. If there's time.
Call you. Okay.
So I am registered. again, it's not a very sophisticated user interface. Somebody called OpenSIPS is registered, somebody called Charlie is registered.
And I'm OpenSIPS and I'm calling you. It says call unfortunately.
Oh, there we go.
Hi.
Hi, and we have video and audio.
I'm not sure if my microphone works. Guess it does.
Cool. Sorry, I was just looking at that and expecting to see me, but I assume you can see me, right?
Yeah.
Yeah, brilliant. Cool. Yeah, so we have video and audio in 2 directions, which is the holy grail. So there we go. And I have a quick slide just to demonstrate what's happening. Again, it's for people to look at in the future if they want to refer back to what happened. But say, as I said earlier, the Chrome web browser here, he has no idea what IP address, what the local IP address is. It's coming through a router of some description, maybe more than one router. All OpenSIPS knows about is the source IP address and ports here. So that's all OpenSIPS can talk to. And we must use the fixed NAT and Register function in order to know how to route the requests and responses. And it's the same on the other side. And again, just a quick overview here of how we have to do the same thing for invites. So now for something a little bit more complicated. I'm going to change the configuration so we can send the call to the PSTN. Now, if anybody's worked with the PSTN gateway before, you'll know that they probably don't move as fast as Chrome releases move. So a PSTN gateway will know how to talk SIP and it will know how to read SDP. But in my experience, they are very particular about the codecs they will accept, the media types they will accept, and generally they will be very strict. So they would not like, I'm just going to make this call again just to demonstrate. They would not like the SDP that's been generated here. They would not, because you're calling the PSTN, it's an audio-only call, even though this may be valid. The PSTN may just reject the call outright if it sees any video media in there. But in my experience, some of them don't like to see the candidate information. They will just reject the call outright because they can't parse it. They don't like the encrypted RTP specification here. They usually like to see AVP RTP only. So a PSTN gateway will like a very kind of standard form of SDP, and that's the challenge now. Is to we now have this browser, which is an amazing user agent. I mean, if you're developing a piece of software for your customers, you no longer have to give them Xlite or Bria or Zoiper or any other number of clients. You don't have to tell them how to fill in a proxy, how to fill in the username and password, how to configure a stun server, how to change UDP, TCP. Your support team don't have to deal with that. In the kind of modern world of building applications in a web browser, this basically allows you to build your user agent in a web browser and deploy it wherever you want. Your customers can run it on the handsets, they can run it in the web browsers. It's a real nice sort of piece of functionality that OpenSIPS has now that allows you to do this. So as I was saying, the challenge is now, okay, well, I imagine most people will want to use their user agents to make a PSTN call. We have this nasty SDP that the PSTN will want to understand. So essentially we need to convert it. We need to convert it, and we can convert it with RTP engine, which is almost like an improved version of RTP proxy. It can run in user space or kernel space, an RTP engine, and rather than just giving OpenSIPS a new IP address and port, so as you can see in the SDP here, you've essentially got an IP address and a port. RTP proxy will basically give OpenSIPS a new IP address and port to put in the SDP. RTP engine can absorb the whole SDP from OpenSIPS, and it can give you a brand new SDP to send forwards. So on one side, it can accept full-on ICE SDPs, such as the one you can see here, and then it will give OpenSIPS back a nice small SDP that a PSTN gateway can understand, and then it can do the same in the other direction. So it's a very nice little module that's available to use in OpenSIPS. It's very easy to install this RTP engine. You can just download it from the website, create some Debian packages, and install them. It installs the kernel module, and then away it goes. So I've already actually got it installed on here. So RTP engine is running. The IP address it will give out in SDPs is this one, which is the IP address in the box. 161.31.61.38. We have here defined an IP address and port, which is the IP and port that OpenSIPS can use to control RTP engine with. And we have some minimum and maximum audio ports that we're going to allow RTP engine to give out. So once again, we just dive into OpenSIPS configuration. We'll load the RTP engine module. And we need to tell OpenSIPS how to control RTP engine. So getting back to the documentation, RTP engine socket. So we will just use this line here. And I believe it was 12225. So it's simple, literally all that's needed to load this module, and the basic way we're going to use it is to load it and then to tell OpenSIPS how to control it, as simple as that. We then need to go back into our invite and tell OpenSIPS how to handle a call to the PSTN. So here we have the block of code that OpenSIPS uses to handle an invite. We are fixing our NATed contact header. So we basically need to have a very simple if statement to detect whether the call is going to another user agent or to the PSTN. And for the purposes of this, I'm just going to say if we are a numeric. So basically, if you dial the number, then this call is going to the PSTN. And what we need to do is we need to tell OpenSIPS to make an offer to RTP engine and get some new SDP back. So we need to call the RTP engine offer function. And into there we need to pass some parameters. Now we know, because this is a very limited demonstration, we know the call is coming from a WebRTC client. And we know the call is going to a PSTN gateway. So we can look at the documentation in the RTP engine module, and we can basically say that the PSTN gateway is going to, we want to replace the origin, so we want to replace the O line. So here we have the O line, it says 127.0.0.1, we're going to replace that with the public IP of the server. We're going to replace the session connection. So we're going to replace the C equals line. At the moment that's been set to a public IP that the browser has decided on. So we're going to replace that again with the IP address of RTP engine. We're going to look at the ICE option here, and we're going to tell it to send no ICE information to the PSTN. So we're going to use ICE equals remove. So all the ICE candidates will be removed. And then we're going to use a very simple RTP and AVP RTP protocol for the PSTN. So we basically just need to pass this information to the function. Just verbatim, just ICE equals remove. And then we just want to use RTP AVP. As simple as that. And then we're going to send the calls to the PSTN. So I will change the request URI to be one which will go to the PSTN. The call, I've got another copy of OpenSIPS running on this server. Kind of outside the scope of this demonstration, the PSTN doesn't like big packets. If you're sending SIP over UDP, then you typically can't go above 1500 bytes. And so I have another copy of OpenSIPS running on the same server, which will take the request and use the topology hiding module, strip it down to a very small request, and it will also remove the video element of the SDP. So I'm going to send the call to myself on port 5017. And then I'm going to relay the call. Relay is a standard function that comes with every OpenSIPS script. It essentially just calls the TRelay function. Yep. So the call will come in, we will fix the NAT contact, we will detect that we have a numeric request, and then we will get some new SDP from the RTP engine module, and then we will send the request on to the PSTN. Now we have to deal with the problem on the other side. The PSTN will respond with a 200 OK. The 200 OK will be a regular SDP, and we need to then change that back to an ICE SDP that the web browser will be able to understand. So in the reply route, we can do an RTP engine answer call. And we need to give it some information that the web browser will be happy with. I'm just going to refer to a different configuration of this. So it's essentially, we are sending back to the web browser essentially what the web browser has sent out to us in the first place. It should be as simple as that. Let's restart OpenSIPS. Hopefully it will restart. I'm going to restart up the OpenSIPS, which is going to connect to the PSTN gateway. Running on port 5070, and then I will run a trace so we can see exactly what goes on as the packets come in and are routed through OpenSIPS. So back to our web page. So we'll register, and then I will call my own mobile, unless anyone else wants to offer up their mobile number for me to call.
Yeah.
Call my own. Okay. Try again. No ringing this time. It says it's ringing, but the phone is not actually ringing. I'll try one more time. I'll still be able to show you what's happened, even if it doesn't work again this time. Hello? 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 So again, we have audio in both directions, which again is the holy grail. So, and again, you know, the phone, this is the phone anywhere in the world, and it's talking to a web browser, which is pretty nice. So just to give you an overview of what's happened here, I've just run a trace on the server. You can see OpenSIPS here. This is the control port for RTP engine 12225. OpenSIPS has sent the entire SDP to RTP engine. So an RTP engine should reply with a much smaller. There we go. Here's the reply back from RTP engine. It's a much smaller SDP. It's only got RTP ABP as the RTP type. There's one port. There's one IP address. All the candidates have been removed. All the encryption information has been removed. Like the ICE candidates. And then we see the invite going from OpenSIPS to our locally installed OpenSIPS on port 5070 with the brand new SDP. And then the locally installed OpenSIPS should then strip out the video, which it hasn't here. I'm not sure why, which is why one of the calls failed. So I'll just find the one that did work. Yeah, so this is what did work, and you can see that what we've actually ended up sending to the PSTN, you know, we started off with this huge SDP here, and we've ended up with this nice compact one that the PSTN understands, and on the way back, we should have a 200 OK. Yeah, we have a 200 OK. The SDP has been sent back into RTP engine, and RTP engine has given us back ICE compatible SDP. So the audio is actually relaying. Okay, thank you. The audio is actually relaying through RTP engine, but we managed to bridge to a PSTN gateway from a browser. And again, as I said before, you can now deploy user agent into a browser, which I think is a much nicer user experience. For any user really. Again, I've got a little slide that kind of demonstrates what's happening here. Again, you've got your WebSocket connection open to OpenSIPS on the browser. OpenSIPS can talk to the edge of the router, which is the blue line. OpenSIPS can talk directly to the PSTN. Very rarely will be behind NAT. It will almost always be a direct IP connection to your PSTN gateway. And the RTP has been diverted through RTP engine and fixed up in a way that the PSTN understands. Yeah, so just to summarise really, I think what I've already said, before, the browser can now be used as SIP user agent. It's much easier for end users, no software, no proxy username, SSL certificate for a TLS connection. The standard delivers secure voice and audio, so you know it's always going to be secure and encrypted regardless. Chrome won't actually make the WebSocket connection unless it's a WebSocket secure connection, which is a challenge for say this demo, but it's great, you know, out in the real world because you know it's going to be encrypted. The ICE negotiation kind of helps you out a lot with any NAT traversal for your media. And this is, I mean, I've just taken a bog standard OpenSIPS configuration file, made a relatively small amount of changes to it, and been able to do what we've just done. But if you've already got an existing OpenSIPS configuration, you can easily add this kind of thing alongside it. You could add an OpenSIPS box registrar to the side, which just proxies registration requests into your regular OpenSIPS box. You know, it's a very easy thing to add into an existing installation, and you instantly get this ability to handle WebRTC calls. And again, there's not enough time to demonstrate this, but because you've got a user agent in your browser, you've now got the ability to handle presence in your browser and messaging in your browser, so you can have a full-on kind of unified communications client. Should you wish to write one in JavaScript or HTML or whatever technology you choose. So I hope that's been useful, and thank you very much.
Thanks, Pete. Wasn't that awesome?
Any questions?
Yeah, we've got like maybe time for one quick question as Razvan sets up.
Okay.
Colors.
Does the browser handle the audio in the PC itself?
Yeah, I don't claim to fully understand the technicalities of what the browser does, but it can. Sorry, Jonathan, I wasn't ignoring your hand up first. The browser has the ability to gain access to your camera and to your speaker and microphone. You have to actually give it permission the first time.
Right.
But yeah, once it does that, it can just go away and send all the media out that it needs to. Jonathan?
Is OpenSIPS having to do much more work from a security perspective than a standard OpenSIPS deployment? Do you expect it to have any capacity limitations?
I believe it will just be having to do a standard TLS negotiation of the WebSockets connection, and it also, I guess it's decrypting and encrypting the various messages as they come in and out of the WebSocket, and it's having to hold open the TCP connection as well. But I think that's a general downside for any kind of TCP connection into OpenSIPS. As you know, you restart OpenSIPS, you lose the open connection. So, but I don't believe, unless Razvan wants to contradict, that it's any different to having a normal TLS and TCP connection.
No, it's just a TLS connection that has some message indication like length, stuff like that. So it's just easier to use. That's it. But at the end, it's also a TLS connection.
Doesn't ICE require a stun server?
It does, and I believe Google being Google and that Chrome being Chrome, that Google just basically query their own stun server. They have their own list of stun servers set somewhere, like the DNS servers they have.
So you don't have to set one up on
No, the browser just deals with it itself. I don't even know if you can specify an override. I've not looked at that at all. But that's the nice thing about it. It just does it for you.
Thanks, Pete. So up next we've got Razvan. He's going to talk about distributed data using the clusterer module.